So what we're going to do in this video is go through how functions work and some of the small things we need to know about them. So we're going to get into a test file here, and we'll just call it test.c. We're going to kind of ignore the big things about writing an application in C or anything. I just want to kind of give you some very basic overview of functions. So let's say that we have some code that we want to do different things. So the first thing that we're going to have is we're going to have a main function, and I'm going to ignore all the extra stuff that goes into a C function, but we're going to have a main function. And like I said in an earlier video, this is where the system comes in and starts the application. And Objective-C, Java, all of those types of programming languages all have some type of a main function or main entry point. Python also, if you're going to execute it at the command line, it has the concept of having a main entry point for the program to start executing at. So this is where we're going to start, and let's say that we start to write this code, and let's say that we need to set a variable here, and we'll just say this is an integer, and we're going to make it be called I, and we're going to set it equal to 4 plus 5, and then down here we're going to tell it to say name equals and I'm just gonna, what is your name? Again, I'm not doing proper C code here, so don't try to duplicate any of this. I'm more after the prime point. So, and then down here we're gonna we've already got I defined, so we're gonna set I equal to 6 plus 4 divided by 3, and then we're going to do some other code. So we're just going to, keep going down the list here doing things. Now, there's a couple things to note. The first are the curly brackets. The curly brackets actually allow us to group code together, and you're going to learn a little bit more about that when we get into our if and for loops and those kind of things. But the curly brackets and whatever the programming language uses that you're writing code in, it'll have some way to block, and it's just called code blocking, but it's blocking your code so that you know that if we enter the main function here, and this is a function, it is going to execute everything between these two curly brackets. Now I'm going to come down here, and if you can imagine, this is the first example that I gave you where we write one main function and everything that we want to do inside that program is done inside of the main function. But let's say that there's some other places where we want to get name equals what is your name again, because we got to make sure that we're keeping up with the right person and getting numbers and other kind of stuff. So the first thing I want to do is I want to write a function, and we'll just say that this function is going to return a string, and it is called what is your name. And we're not going to pass it any variables because it's going to actually do all the work on its own. And so inside of here, we're going to define a variable, and we're going to say st, or we'll just call it name, equals, and we'll say what is your name. Okay, and then we're going to return name. So we're going to return the name of this function back to whatever calls it. Now, what I'm going to do, and I'm going to cover a couple things in this video. One is commenting your code. There's two aspects to writing good code. One is writing good code. The second is writing code that is either self-explanatory or that has enough comments in it to catch someone that didn't write the code up to speed as quickly as possible. Now, I am big at commenting. I think that I don't think you can comment enough. Now, obviously, there are aspects where you could put too many comments in and you can't find your code, but really any good editor can kind of get the comments out of your way. So as an example, I'm going to put in a comment here. This function asks for the username There's a couple things to note. One, I did not, in the aspect of actually coming in here and writing code, this area here is not very wide. You'll notice my screen is really wide, but I'm keeping my code as narrow as possible. I generally try to keep it under 100 characters if possible. The reason for that is because then you're able to review your code on a number of different interfaces, or I can even stack code up side by side and be able to see what's going on. The other thing is you'll notice that I've added a comment, and these forward slashes work in most programming languages. Not all programming languages, but in most programming languages, those two forward slashes are going to allow you to do a comment. It really is a good idea to put as many comments in your code as you can to make sure that that anybody that's coming in here to look at the code later on can understand what it is that function or that line is doing, so that we can get moving as quickly as possible. Now I also want to add another function here that's going to return an integer, and we're going to call it add numbers. And I'm going to pass it in an integer called I1 and another integer called I2. Now there's a number of different ways to do this, and it really depends on the language, but I'm going to say that we've got an integer called sum, and we're going to set it equal to I1 plus I2. And then we're going to return sum. Now, a couple things. First, this is adding numbers for our total invoice or whatever it is that we wanted to have this function do. And there's a couple notes to make here. The first thing that I want to kind of say is that this is the name of the function in most programming languages. Now, Objective-C, that's not the case, and I'll get into some Objective-C in a little bit. But in C and Java and anything else, this is the name of our function. These are our variables that we are sending into the function. Now, what I'm going to do really quick to kind of explain, to help you understand what we're doing here. Let me get back to where I can type. So what I want to do is we're going to go up here into our main function, and where we were adding this number, I'm actually going to replace that, and I'm going to say integer answer equals, and we're going to call our function. So our function was called add numbers, and we're going to pass it, in our case, 2 and 3. Okay. Now there's a couple things that you need to be aware of, and it takes a little bit of time to really understand what it is that's going on here. But the first thing is that whenever we do a function where we're programming something to do a certain task, you have the property of calling the function, and then you have the actual function itself. Okay. Now you'll notice that I am passing this a 2 and a 3. Let's say that I need to call this again, and I'm going to do an answer here, and I'm going to say I6 and I7, and I want to say I6 equals 4 and I7 equals 5. And then we're going to say int answer 2 equals add numbers, and this time instead of sending the numbers manually, we're just going to put these variables in. So you can kind of pretend that this is a situation where the user gave us the numbers that they want to add, and then we're calling the add numbers function to actually add them together. Now, this is a very important thing to understand. It does take a little bit of thought to kind of get it in your head, but notice that this variable and this variable, in fact, let me start that over. This variable here is called I6. This variable here is I7. these two variables are being passed into add numbers, but notice that add numbers is actually declaring an integer called I1 and another integer called SI2, which that was a typo. But the point here is that these variables are what's being passed into this function, but inside of this function, we don't refer to I6 and I7, we refer to I1 and I2 because that's what we actually declared as being our variables for inside of our function. So these variables have what's called scope inside of this function call. These variables here do not have scope inside of this function because they were passed in as a value to this particular function. Now this is a little hard to explain and a little hard for you to grasp, but scope is the process by which the computer language, the programming language, isolates certain variables into certain functions. So in other words, this is our main function that we're in here. So I6 and I7, these two variables here, have scope. So these have scope inside of the main function. They do not have scope down here inside of this function. So notice our curly brackets here. This is inside of our add numbers function. So while this function can reference and work with this I1 and 2, it cannot work with I6 and 7, nor can this function try to get to the values of I1 and I2 because they have scope inside of this function. So scope is a way for you to make sure that your variables don't cross over each other. Now you can have what's called a global variable, and a global variable is where I declare a variable up here outside of the main. So it's not inside of anything, therefore it is a global variable, and a global variable can actually be referenced by all of the functions inside of your program. Now, the problem with global variables is that if you, let's say I name a global variable I6, and somewhere in some obscure function somewhere else, I accidentally declare a variable called I6, and I set, and I don't declare it, I actually just set a variable called I6 equal to 2. Well, what I just did is I overwrote my global variable that was supposed to hold 22. I just overwrote it, now it equals 2. And those types of bugs are extremely hard to track down because because of that scope and the fact that every function in the program can have access to that global variable. So typically global variables are frowned upon because it is difficult to manage them. Now, if you name them correctly, for example, I usually name all of my global variables with global on the front so that there's absolutely no doubt that that variable is a global variable. You can use case, where I make everything all uppercase for global variables. There's all kinds of different ways that you can dictate that that's a global variable to try to prevent yourself from making that mistake. But just note that if you do have a global variable, and there are always situations where you need to have a global variable, depending on what you're trying to do. So I'm not by any means saying that you can't have global variables. You will need them. But just make sure that you name them in a way that they make sense. Now, while we're on the naming process, this I6 and I7, as well as SI1 and 2, or I1 and 2, they're not very good names. They don't really tell me what it is that I'm working with here. So typically you want to try to name these things so that they make sense. Again, the better you name your functions, the better you name your variables, the less comments I've got to put in the code, because anybody looking at it can pretty much figure out what it is that we're supposed to be working with. So there's no real limit to the length of your variables. You do have to type them, so you don't want a 25-character variable name because it'll get old trying to type the thing out. But you do want to try to name them in a way that you can get to them and understand what they are. Then in a function that's as short as this function is right here, naming them I6 and 7 is not really that big of a deal, because I can kind of see what's going on here, and it's not necessary for me to get too much more detailed on those naming. But you know, pay attention to your names that you name these variables and all that kind of stuff, because it does help out a lot when you go back to look at your code. Now, the last thing I want to kind of point out is the flow of this program. If we, and let me clear the stuff we've got on here real quick, and I want to add one more thing here. So we've got what is your name, and we're going to come up here and we're going to replace this, and we're going to say string name equals what is your name, and then we'll just get rid of this, and then we're going to take this and replace this guy with 2, and we'll let that be the name there. So a couple things. What happens here when we go through and start working with this particular program is this is our entry point. So we'll label that 1. This is the first line of code that gets executed when we run this program. The next thing that happens is we land on line 6 here, and we've got a local variable called answer that we're actually wanting to set equal to adding numbers 2 and 3. Now, when we hit this line, the program is going to leave main. It's going to come down here and it's going to execute add numbers. It's going to take 2 and it's going to make it equal I1. So in this situation, 2 is equal to I1, 3 comes down here and equals to SI2, and ignore that S, it's not supposed to be there. So the system has called this function, it's passed in these 2 variables, it has matched this function, so it needs 2 variables, it got 2 variables, and it has the name that it's looking for. So everything that we're trying to do here is all matching up. So then the code executes this line. So this is our second point that we're going to actually enter into, and it adds these 2 numbers together. And ignore this, I don't know why I put that there. It adds these 2 numbers together and sets them equal to this variable. So now I have a local variable that only has scope inside of this function. So again, I can't get to sum out here. I have to somehow return the value, and then that's what this line's doing. This line is actually telling it to return sum. That then turns around and comes back up here and sets 2 plus 5 equal to, or 2 plus 3 equal to answer. So now answer equals 5. So at this point, answer equals 5. So the next thing it does is it declares 2 variables. It sets them equal to 4 and 5, and then this function gets executed. So I'm going to clear this off, and this function gets executed. Again, add numbers, comes down here and calls this function. It sets this time whatever I6 is equal to this variable. It sets I7 equal to this variable, and we call it again. So now sum equals those 2 variables added together, which in this case is a 4 and a 5. So now sum is equal to 9. We return 9 back up here, and it gets stuck into answer 2. So now answer 2 equals 9. So we got answer 2 is equal to 9. And then it comes down here and it declares a string name, and it calls what is your function, or I'm sorry, what is your name. So this turns around and calls this function, what is your name. You'll notice there's no variables here, there's no variables here, so everything matches up. The compiler's happy and the program executes just fine. It sets string name equal to what is your name, and then it tells it to return name. Again, name only has scope inside of this function. It then returns that value up here and sets it equal to name. Now this name is not the same variable as this name. So I'm going to get in the next video kind of talking about pointers, and you'll see that these are literally 2 completely different points in memory, even though they do have the same name. When this function exits, this variable is destroyed. It's gone. There is no variable called name inside this function anymore. And whatever it pointed to is actually returned up here. And now this name here is equal or is pointing to whatever their name is. So if it was Sue, this variable now points to Sue. So just to finish this video off, we then have add numbers that turns around again and calls this. We have two variables here that again get set to I1. This variable goes down here and gets set to I2. We add it together, we return it, and then it comes up here and sets T1 or I2 equal to that. So when we're writing these functions, you need to understand completely exactly what is going on when you're calling these functions and how this stuff is adding up. If you ever have to come in here and debug an application, you will find yourself literally stepping into each one of these functions, looking what that variable is. What is it equal now? Okay, we're returning some, so now this is equal to that, and looping through and trying to figure out what's going on with your code. So being able to understand and step through one line at a time is an extremely valuable skill, and you need to make sure that you understand exactly what we're talking about here.